Okay, 9.4, we're talking about the tangent ratio. The tangent. I hope you've seen tangent before. It comes from sine, cosine, and tangent, which is what we'll be working with today. Sine, cosine, tangent, we're going to be working with tangent. Maybe you've heard this phrase before. I hope you have. Sorry, we'll do it in color order here. So, SOHCAHTOA. Okay. SOHCAHTOA. Again, we're going to be working with this right here. So, SOH is the sine, and sine is OH, which is opposite over hypotenuse. Okay. Ca is cosine, and it's A over H, so adjacent over hypotenuse. And TOA, tan, is the tan, and O and A is opposite over adjacent. And that's what we're working with today. Opposite over adjacent. The tangent of A is the length of the opposite leg of the length of the leg opposite of angle A. So angle A right here. What's opposite of angle A? Opposite is that side opposite that angle over the side right next to that angle, adjacent. Opposite over adjacent. Remember, we don't use this hypotenuse in tangent. Okay, how do we know it's a hypotenuse? Well, it's opposite that 90-degree angle. Okay, so the tangent of angle A should be opposite over adjacent. Okay, so BC over AC. Down here, we're just going to be doing some ratios. Let's first start with the tangent of A. And let's go this big triangle here. A, B, C. Okay, where BC is, B is at 8, 6, so 8, 6. C is at 8, 0. Okay, so what's the length of this leg here? It's 6. So we know that the tangent of A and BC over AC is going to be 6 over, what's our length here? 8. 6 over 8, or 0.75. And it says decimal, so 0.75. I went ahead and made it on this GeoGebra. It looks a little sloppy here. I apologize. We want to find this next one, KD over AD. Well, that's this leg here. Okay, my labels are a little off from the one in your book. Let's find that length. I go here and go to distance. And I want to know where this point E is at. It says 5.25. Okay, so 5.25. This is at 5. Oh, it's at 7, comma 5.25. So 5 1/4. So my tangent of A, this angle here, is 5.25 over 7. Okay, and we want it as a decimal, so what is 5.25? 5.25 divided by 7.75. This here is 0.75. Let's do one more. LE and AE. I want my distance. This is at 4.5, so it's 4.5 over 6. What's that fraction? 4.5 divided by 6, 0.75. And I think you're going to catch on to the pattern here. Nope. .75. Okay, all of these are going to be 0.75. Okay. Why is that? Well, in our construction, we took each point on our x-coordinate, right here, 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 and made a vertical line. Okay, so these should all be equivalent ratios, right? All equivalent ratios. That's what our point is here. If I scroll down, use a calculator as a tangent key to calculate the tangent of 36.87 degrees. You get the same result. So why 36.87? Our angle A here, our angle A is 36.87 degrees. 36.87 degrees. We want the tangent key in our calculator. So we want to know, this is the tangent of 36.87 equal to 3/4, or 0.75. So if I go into my calculator, this is very important, very important. I'm going to go to mode, and see this key here is in radian. We want it in degree. Why do we want it in degree? Because of 36.87 degrees. We're not talking radians, we're talking degrees. And I'm just going to punch 36.87. I'm going to say tangent, that tangent key there, of 36.87 degrees is equal to 0.75. Okay, well, 0.00, whatever. 36.87 is equal to 3/4. The reason it wasn't exactly 3/4 is because I didn't plug in this entire decimal down here. We just rounded. Okay? All right. Let's scroll down. I'm not going to repeat that exercise. Okay, I'm actually going to scroll down to here. Down to our notes. The first one, trigonomic ratio. The trigonomic ratio, or a trigonomic ratio, is a ratio of the lengths of two sides in a right triangle. The tangent is a trigonomic ratio, so a trig ratio for acute angles that involves the lengths of the legs in a right triangle. That's legs. Right triangle. Okay, so what is that? It is opposite over adjacent. Opposite over adjacent. That's tangent. The angle of elevation the angle that an upward line of sight makes with the horizontal line. So the angle upward line of sight makes with a horizontal line. Okay. So for example, if you were, let's say there was a plane up here, and the plane, here's my best drawing, there's my wing. Okay, and I'm standing down here on the ground, here's me. Let's say that angle of elevation to that front of the plane is, let's say, 68 degrees. Okay, so my angle of elevation from where I'm at to that plane is 68 degrees. Okay, we're talking this angle here. Okay, that's angle of elevation. And to me, that's a pretty dang good plane. Pretty excited about that. Next, here's our tangent ratios. Remember, opposite over adjacent. Here we go. In exercises 1 through 3, we're going to find the tangents of the acute angles in the right triangle. We're going to write each answer as a fraction and as a decimal rounded to 4 decimal places. Okay, so we're going to find the tangents of the acute angles. So here we have angle R and angle S. So the tangent of R is equal to 45 over 46. Or, sorry, not 46, my bad. 45 over 24. Okay, why is that? Well, we go opposite over adjacent. They also want us to write this in a fraction, so what's 45 divided by 24? As 1.875. Okay. Now, the tangent of S. Remember, we go opposite, so 24, over adjacent. What does that equal? 24 divided by 45. That's equal to 0.53 repeating. So 0.5333. Next one, in our next problem. Let's start with J. The tangent of J equals, remember we go opposite, 7 over, opposite over adjacent, so 7 over 5. We can divide 7 divided by 5, we get 1.4 equals 1.4. Next, tangent of L. Remember, we go opposite. So 5 over adjacent. And that's equal to 7.1423. 0.7, sorry. 0.7143. Yeah, this is 1.4. Last one. Remember acute angle, so we're going to start with angle A. We go opposite, so 2 over adjacent, so square root of 6. Nope, sorry, that is the hypotenuse. Almost made a mistake. Do not make the same mistake I just made. The tangent of A is equal to 2 over, that's hypotenuse. How do I know it's a hypotenuse? Well, it's opposite that square, or opposite that right angle. What's adjacent to angle A? The square root of 2. What's 2 divided by the square root of 2? 1.4142. 1.4142. 1.4142. Okay, and the last one, we want the tangent of C equals opposite, square root of 2, over adjacent. Don't make the mistake. Remember, it's 2. Square root of 2 over 2. Which would be 0.7071. 0.7071. Okay. Now, in these next exercises, if you didn't understand the first part, those 1 through 3, then we cannot move on to here. So we have to make sure we remember those first 3, or how those are set up. Okay? We want to find the value of x. Well, the value of x is right here. We want the tangent of 10. Sorry, I'm writing that like a fraction. The tangent of 10 degrees. That's going to be equal to opposite over adjacent. So 5 over x. Okay, now we can solve tangent of 10 degrees. Okay, tangent 10 degrees. That equals 0.17. Remember, I have to make sure that it's in degrees. It is. Good. So we have in our equation 0.763. Sorry, 0.1763 equals 5 over x. Okay, now how do I solve for x? Well, I can multiply it by x on both sides. Okay, x's cancel out. So we're left with 0.1763x is equal to 5. And we could divide 5 by 0.1763. Okay, and that's going to solve for x. 5 divided by 0.1763 equals 28.4. Okay, instead of equals, I'm just going to write about. X is about 28.4. Let's try it on number 5. Number 5, we have, let's see, we can do the tangent of 64 degrees. Tangent of 64 degrees. That's going to be equal to opposite x over adjacent. We could also set this up as a ratio, right? Tangent of 64 degrees, that can be set over 1, anything over 1. Now what can I do? I can cross multiply. So I can say 13 times the tangent of 64. So it'll be equal to 26.65. That's going to be equal to x, right? Yeah, because 1 times x. So x equals 26.7. It roughly equals 26.7. All right. Number 6. Number 6, I can take the tangent of 31 degrees, so tangent of 31 degrees equals 24 over x. Set this over 1. And then I can cross multiply. Right, so I'm going to have x times the tangent of 31. So tangent of 31 times x equals 24. I have to divide 24 by the tangent of 31. That's going to equal 39.9. So x is roughly 39.9. Okay. Next, we have triangle CDE, where E is the right angle, 90 degrees. Okay, so here's E, here's C, here's D. Okay, and the tangent of C is 4 over 3. Remember, opposite over adjacent. Find tangent of D. Well, opposite of D is 3, so 3 over 4, done, equals the tangent of D. Not too bad there. Let's scroll down here. Number 8. The environmentalist wants to measure the width of a river to monitor its erosion. From point A, she walks downstream 100 feet and measures the angle from this point to C to be 40 degrees. So this angle here is 40 degrees. How wide is the river? So we want to know, how wide is X here? Round to the nearest tenth. Well, we can set up a tangent ratio, right? The tangent of 40 degrees can be equal to X over 100. Cross multiply. We're going to get X equals tangent of 40 times 100. The tangent of 40, gotta go up even further, 40 degrees equals that. Multiply that by 100. We're going to get 83.9. X equals 83.9. What does it say around here? Yep, nearest tenth. Is it feet? Yep, 100 feet. Feet. All right. Next one. One year later, the environmentalist returns to measure the same river from point A. She again walks downstream 100 feet and measures the angle from this point to C is now 51 degrees. So now this is 51 degrees. By how many feet of the width has the width of the river increased? Okay, so it might be helpful to remember that this was 83.9. Okay, so let's find our answer here. We're going to say the tangent of 51 over 1 is going to be equal to X over 100. Okay, so we have to take 100 times the tangent of 51 equals 123.5. So X is now roughly 123.5. And now, that's not what it's asking. It's saying how many feet has the width of the river increased. So I just subtract that from this answer here, and we get 39.6 feet. So roughly, so about 39.6 feet. Okay, that's how much the river has increased its width. Now we can move on. Now we can move on to number 9. Last problem. That's in the notes. Oh, no it isn't. We have 2 more. I lied. A boy flies a kite at an angled elevation of 18 feet. So we have a boy here. There's our kite. That's 18 degrees. Okay. The kite reaches its maximum height of 300 feet. Wow. Nice kite. Oh, away from the boy. What is the maximum height of the kite? That is not 300. The kite reaches its maximum height of 300 feet away from the boy, so this is 300. Okay, I was wrong. Here we go. We have a right angle. Or we have the height of elevation is 18 degrees. That's fine. Okay, this is written poorly. The kite reaches maximum height 300 feet away from the void. That's where it reaches its maximum height. Okay, so it's 300 feet away. This is our distance on here. So now we can set up tangent of 18 degrees over 1. That's going to be equal to x over 300. Remember, we cross multiply. So we're going to get x is equal to 300 times the tangent of 18. So 300 times the tangent of 18 degrees, 97.5 feet. Roughly.